The rocky volcanic islands of Hawaii and the cracked ridges of the western United States were formed by violent, catastrophic upheavals of the Earth's crust. Earthquakes and volcanoes are the result of powerful forces colliding, and they have ravaged the Earth for millennia. This is what happens when the plates of Earth's crust shift. And this is what it feels like.
We were lying in bed.
I was in bed, as I think a lot of people were.
And all of a sudden I felt the earth shaking really hard.
I woke up and everything was shaking.
I remember waking up and being very scared at first and not knowing what was going on.
I knew that it was an earthquake.
It's not a shaking like anything else. It's kind of subtle, and then it like grows all bigger, and
it feels like you're surfing on a board.
It's not like
you know when it's an earthquake.
An earthquake with a magnitude of 6.7 hit an area outside of Los Angeles, California in 1994. This was the most damaging quake to strike a major U.S. city since 1906, when San Francisco was hit. Freeways toppled, buildings collapsed, and shattered gas mains fueled fires that raged into the night. What are the forces that cause these earthquakes along California's coast? The best explanation comes from the theory of plate tectonics. The Earth's crust is broken into large pieces called tectonic plates. The plates move very slowly, but they are responsible for creating oceans, valleys, mountains, and volcanoes over time. As the plates shift and collide in different directions, they create cracks in the Earth's crust. These are called faults. One of the most famous is the San Andreas Fault, which extends 600 miles from northwestern to southeastern California.
The San Andreas allows the Pacific Plate to move horizontally relative to the North American Plate at about 3.5 centimeters per year, about the rate your fingernail grows.
Pressure building up along a fault causes an earthquake. Seismology is the study of earthquakes. Seismographs record and measure ground vibrations.
You can imagine the surface of the Earth like the surface of a pond, and the earthquake occurring is like tossing a pebble into that pond. And the waves propagating away are just like the rings propagating from the pebble in the pond.
Scientists once measured earthquakes using the Richter scale. The squiggles recorded by a seismograph indicated how much the ground shook during a quake. But today, seismologists use moment magnitude, a different measurement. Moment magnitude measures how much total energy was unleashed during the earthquake and converts those numbers into the familiar Richter scale. By mapping the locations and sizes of recent earthquakes in an area, scientists hope to discover a pattern that will allow them to predict where and when similar earthquakes are likely to occur. Many volcanoes are located along fault lines. When pressure builds from the heat of magma deep within the Earth, it creates gas, which may cause the magma to erupt. Now the magma is called lava, and it can reach temperatures greater than 2,000 degrees Fahrenheit. Volcanoes are classified depending on how often they erupt. Mount St. Helens in Washington State was a dormant, or inactive volcano until it erupted in 1980. When a volcano is active, it is constantly erupting. Volcanoes are also classified by the type of eruption. In Hawaii, most of the volcanoes do not have large, violent eruptions. Instead, the lava flows from several cracks or fissures in the Earth's crust. In fact, volcanoes created all 137 Hawaiian islands and the more than 114 Aleutian Islands in Alaska. Volcanoes and earthquakes are the most visible and dramatic reminders of the powerful forces at work beneath the surface of the Earth. Studying tectonic shifts and collisions helps scientists predict when the next quake or eruption will happen. And knowing that will tell us when to get out of the way.